Hey everybody, I just wanted to make this video to go over the questions that we're going to be talking about in class today. I apologize for not being there. Starting with question number 2 here. So I know you can see the work that I have here and the answers, but what you want to recognize here is this function is measuring a domain of n, the number of observed vehicles. So we're talking about number of vehicles, so that go through a specific intersection. So we could be talking about 1, 2, 3, 4, etc. So these numbers, if you look at choice 1, this is integers less than 0. So we're talking about negative. That doesn't make any sense here. A negative number of cars, so that's out. Whole numbers less than 1, you'd be talking about 0, -1, -2. So that, again, is out. Rational numbers would include all decimals and fractions. So we're not going to have 1.5 cars or anything like that going through the intersection. So that's out. The correct answer here is whole numbers greater than or equal to 1. You could have 1 car, 2 cars, 3 cars, 4 cars, etc. going through this intersection during a specific time interval. So what you want to do here first is identify what is the domain. It's the number of observed vehicles, then go through the answer choices and figure out which makes the most sense. Okay, let's move on to question 4. Which graph has a domain of all real numbers? What I want to point out here, really important, all real numbers is the same thing as -infinity to infinity. So you're looking at the graph which has a domain of -infinity to infinity. So as you look at choice 1, the problem here is that this stops. It keeps going here, so it would be positive infinity, but there's a closed circle here and it stops. There's not an arrow on the end. So that's out. B, you can see the graph stops here. It does keep going to the right, but the furthest to the left it goes is -4. It keeps going to the right towards positive infinity, but that's going to be out. That's not all real numbers. Let's move down to C and D. On your papers, I don't think the arrows are on the ends, so that's a problem. You're going to have to add those in. I apologize about that. So when you add those arrows in on C and D, you're going to notice this keeps going down and to the left towards -infinity. This keeps going up and to the right, so it keeps going to the right towards positive infinity. So this would have a domain of all real numbers. Same thing with D. This keeps going up and to the left. This keeps going down and to the right. So this is also going to have a domain of all real numbers, or -infinity to positive infinity. E and F. E, you can see, has arrows on the both ends of this parabola. So this is going to continue up and to the left. This is going to continue up and to the right. So as this goes to the left, it's going to head towards -infinity. As this keeps going to the right, this is going to head towards positive infinity. So this is going to be a domain of all real numbers, or -infinity to infinity. And then part F, we got issues. This doesn't ever go past -1 or +6. So that's not a domain of all real numbers. So just to summarize, C, D, and E all have a domain of all real numbers, which means -infinity to positive infinity. Okay, moving ahead to 16. Are these graphs functions? This is just going back to the vertical line test. So if we take and draw any kind of vertical line, you're trying to see, does it hit the graph more than once? Yes or no. And you're looking just simply at that. So here, any vertical line that you draw is going to hit the graph exactly once. B, C, and D are all step functions. On part B, this graph is going to be hit twice by a vertical line. Let me try and draw another line here. It's everywhere there's a closed circle, it's going to count as hitting the line. So it's going to hit the line twice. You can see if I draw a vertical line, let me see if I can make this a little narrower. It's not working. Let's try this again. This is, if I draw a vertical line here, it's going to hit that closed circle and this closed circle. So that's going to make this fail the vertical line test. This is going to pass the vertical line test because all these vertical lines, you have one open circle and one closed circle. So it's only ever hitting once, just at the closed. And then D, you have an issue here. You also have an issue here. It's going to hit two closed circles, two closed circles. So you can see A and C are yes, these are functions. B and D are no. And the reason would be that A and C pass the vertical line test, B and D do not. Okay, last question that you're going to tackle today on your test is question number 9. So this is very similar to one we did during the lesson. So here's what we got. This is just a step function. For a time under 6 minutes, students have to do 4 burpees. So you can fill in the table as you read through this. For a time of at least 6, but less than 8, they have to do 8 burpees. And then a 12 burpee penalty for a time of at least 8, but less than 10. And then there's a 24 burpee penalty for anything 10 minutes or more. So just filling out the table based on that. The nice thing in here is they've given you this information with the inequalities. So you have to come up with the graph. Now, what you want to be mindful of, the time goes up to 0 to 10 and greater than 10. Yes, you could go by ones, but then you wouldn't have too much room to show the graph after 10, so I've decided to go by 2s. Number of burpees goes all the way up to 24. So going by 1s and 2s, I don't think gives you enough room, so going by 4s makes sense. And you want to label your axes. Burpees, time in seconds. So the time is less than 6, but it's got to be at least 0. So that's why you're going to see this closed circle at 0. The number of burpees is 4 all the way up to 6, and then you see that open circle. Then as soon as somebody runs a 6-minute mile, that's going to be a closed circle because it's got that equal to part all the way up to 8 minutes, but not including the 8 because it doesn't have the equal to. It's going to be 8 burpees. So that's why you see closed on the left, open on the right, that next step. The next step, it's got the equal to at 8, but not at 10. And that's going to be a 12 burpee penalty. So this jumps up to this next step of 12. And then anything 10 minutes or more, so 10 minutes or more, that's why that's closed, is 24. So that's jumping up to the next step. And we're just keeping this going to the right because the time could be 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes. So the first step is read through the problem and fill out the table. Once you have this table filled out, then you are using these inequalities here. And again, just adding in, this is going to be somewhere between 0 and 6 to create these steps. This first time interval is going to create this first step, the second time interval, second step, third, and fourth. Then you're going to move on here to this last part, determining how many more burpees Joe would have to do than Raina if she ran a 7-minute mile and he ran a 12-minute mile. So if she ran a 7-minute mile, that's between 6 and 8. So she's going to have to do 8 burpees. He ran a 12-minute mile. He's going to have to do 24 burpees. Subtract those two. He's going to have to do 16 more. So hopefully you found this helpful. You're not going to be doing number 10 on your test. You're just going to be working on questions 2, 4, 9, and 16 and finishing up anything else that you need to. Hope the class goes well. Have a good day, y'all.